all of you. Welcome to DIKU Business Club's webinar about fighting harmful content on the web. It's a hot topic and a global topic. Today we have attendees from both industry and academia and from all over the world, from all of Europe to India and the United States. So welcome to all of you. It's good to see you. I think we have a very interesting program ahead of us. My name is Skött, and I'm head of business and innovation at the Department of Computer Science at the University of Copenhagen. Fake news, hate speech and biased search algorithms have become some of the biggest problems in today's media landscape. Today we present and discuss how we can combat these problems and use AI methods for that. The topic also raises questions that not only challenges our companies, but also our democracy and our society in general. At DIKU, we do computer science, and we have different sections from software, data, people, and society to programming language and theory of computation. And today you're going to meet Maria Maistro from the machine learning section, and we have a brand new section headed by Isabelle Augenstein that you soon will meet. And both Maria and Isabelle have a lot of collaboration with the industry. And one of them is CheckStep, where you will meet Jonathan Manfield. So it's a really interesting program we have for you today. So at DIKU, we apply our work, we collaborate with the industry, our researchers and students establish new companies, and we're building, programming, and sharing stuff that makes an impact to the world. You can see some different examples here from different sectors that we collaborate with and make an impact for. So this webinar is organized by DIKU Business Club, and we are a club for businesses and other organizations. We have more than 60 members, and one of our big events is the annual career fair for IT students, May the 21st. So keep a look on that, the companies here. So today's program, I'll start by say welcome, then I'll give the word to Isabelle soon, and she will talk about towards explainable fact-checking. After that, Maria Maistro about misinformation and search engines. Then we have a short break, 5 to 10 minutes, and then Jonathan Manfield from CheckStep will talk about content moderation, a strategic priority for leaders by 2025, and then a short Q&A session. Today's webinar will be recorded. We will edit it for publication, and if the speakers allow it, we will publish it afterwards on DIKU's YouTube page on the web. An edited version of the slides will be sent to the participants afterwards. So, and if you have questions, please write them in the chat or in the Q&A, and then if there's time in the presentations, the presenters will answer them. Otherwise, we have the discussion in the end. We will take the questions. So to the first speaker, Isabelle Augenstein, Associate Professor at DIKU and head of the new NLP section. So please tell us more about how we go towards explainable fact-checking, and please give a short introduction to your new section and yourself. So
Thank you,
I'll
Anna.
share, so you can share it.
Right, that should work. No?
Yes.
Okay, great. Yeah, so thank you for the warm welcome and the introduction, Anders. So you already said that I'm an associate professor at the University of Copenhagen and head of the new NLP section. In addition, I've recently started a role at CheckStep where I co-lead the research division. And Jonathan will tell you a little bit more about what we do at CheckStep later on. So here in this presentation, I'll focus on my research at the University of Copenhagen. So this first talk will be about fact-checking, and in that context, explainable fact-checking. First, I'll tell you a little bit about what fact-checking is and why we need it. And then I'll do the same thing for explainable AI. And then I'll present some of the initial solutions we've developed for explainable fact-checking. and then I'll wrap up afterwards. Because the audience is very mixed, I won't go into deep technical details here, but I have another talk online that you can watch later on if you want, with some more technical details about these methods. All right, so first, what is fact-checking and why do we need it? Well, the reason we need it is that there are many different types of false information online. So one example here from Corona times is there was a lot of false information that's being spread about Corona. So one is about how Corona can be cured using bleach or alcohol. Then about how Corona is spreading. Those things are very, very harmful to public health. Then it can also sometimes happen that journalists make mistakes due to not careful enough proofreading or insufficient research. And one example is here about a Brazilian politician who was said to enjoy his free time reading Toy Story, watching Toy Story, but actually he enjoys spending his free time reading Tolstoy. So these things sometimes happen, and then newspapers have to correct them. Another example of a type of false information is clickbait. And clickbait means to overpromise information and underdeliver it. And it's become very, very popular. So popular, in fact, that there are clickbait generators out there where you can just enter a keyword and it will give you a clickbaity headline. I particularly like the last one here, 11 ways investing in fact checking can make you a millionaire, which has some truth to it. So yeah. Then I'm sure you're also aware of these satirical websites like The Onion or Rokokoposten that make up full stories just for satirical purposes. So this one here says that Mars is implementing a travel ban after they found a British virus variant. So this is of course it's of course false, but it's still close enough to the truth that people might struggle with it, or machine learning models. Right. And another example are websites which have a very strong political agenda and publish some very skewed articles, like this one saying birth control makes women unattractive and crazy. So it's a description of some scientific articles about the downsides of birth control, but they went completely over the top in describing the side effects. All right, so to sum up here, there are many different types of false information out there. The first one is disinformation, which means that information is spread intentionally and is false. Then there is misinformation, which means the information is false, but it's unintentional. So this example I mentioned about the journalists getting something wrong and then having to correct it. Then there is clickbait, which means to exaggerate information and underdeliver it. Then there is satire, and there is a biased reporting, which is to report only some of the facts to serve an agenda. And when it comes to fact checking, we typically look at these two things, disinformation and misinformation. There are also approaches to clickbait detection, satire detection, and biased detection of biased reporting, but that's not what we typically refer to when we say fact checking. So how does fact checking work? How can one do fact checking automatically at a very, very high level? So here is how one can think of a full fact-checking pipeline. So the first thing is that some kind of statement is given, like immigrants are a drain on the economy. And then one has to determine if this statement is check-worthy or not check-worthy. And there are different things that go into this decision. So one is it even something that's a fact, or is it an opinion? And the other thing is, should it need to be fact-checked, or would people believe it without fact-checking? And also, is it interesting to fact-check it in this particular context? So if you think of a statement like bananas are either yellow or green, that's something everyone knows. It's just world knowledge. No one would need to fact-check that. Another example is when we think of political debates, then the statements which are likely to be check-worthy are things related to the person's political manifesto or such, and not, for example, related to where they were born. People wouldn't want to fact check that. So it seems like a very simple task because it's just a binary classification task, true or false, but it's actually very complex already. And then building on this complex task of claim checkworthiness detection, we have evidence document retrieval, which is something that Maria will tell you a bit more about later on. But it means we have this claim, now a checkworthy claim, and for this we want to retrieve some information, some evidence, which we will then use to decide if this claim is potentially true or false. And we can use some search engine for that or some other types of methods. And then based on this claim and these evidence documents, we want to make several decisions of, do those evidence documents support the claim? Do they deny the claim? Or do they not really provide any useful information about the claim? Right, so here we might have immigrants are a drain on the economy and an evidence document saying EU immigrants have a positive impact on public finances. So that would provide some evidence. And then the last step is called veracity prediction, where given all of these partial predictions, all of these individual predictions, we want to say if overall this claim is true or is false, or if there is not enough information to make that prediction. So this is how it works overall. And as you can see, there are many different components, and usually one trains, say, one model per component. And one of the reasons this task is so complicated is because if errors are made early on in the pipeline, it's usually not possible to recover from them anymore. Okay, so why do we need explainability in this context? Well, one thing I've already told you is that this task is very, very complicated. And so it's important to understand why a prediction is made. When a model is developed, a machine learning model is developed for a specific task like automatic fact checking, then what typically happens is that there is a person called an architect who develops a machine learning architecture, some kind of neural network architecture about what happens to the input and how does one arrive at the output given the input. And then this is passed on to a trainer, again, a person who takes this raw model definition and feed some data into this model to learn how to actually make predictions for a specific domain. And then this model is deployed such that the end user can actually see the predictions. So for example, given a claim, the end user can see, is this true or false, or is there not enough information? But what the end user doesn't see is what happens inside that model. The end user will only be given the final prediction. And this is because these models are usually very, very complicated. So it's difficult to tell them exactly what happened. But it's something we would really need and want. And one reason is that it's important the model doesn't just make the right prediction, but that the model makes the right predictions for the right reasons. An example here is we have a claim in the COVID-19 crisis, only 20% of African Americans had jobs where they could work from home, and evidence saying 20% of Black workers said they could work from home in their primary job compared to 30% of white workers. So this evidence sentence confirms that claim. And if a model selects this evidence sentence to make a prediction, it makes the right prediction for the right reasons. However, what can also happen is that it makes the wrong prediction for the right reasons. So that can be if the evidence says something and the evidence is just wrong, or maybe there is insufficient evidence and the model has just learned to associate certain lexical signals with a positive label. So here the evidence, the example is children don't seem to be getting the virus, and the evidence saying there have been no reported instance of infection in children. Now, based on that, one could infer that children don't seem to be getting the virus, but that's not the conclusion one should draw. Now, another example is when a model can make the right prediction for the wrong reasons. So one thing that happens very often online is that there are these celebrity death hoaxes. So this means that someone reports that a celebrity has died. And this means that, well, that they're hoaxes, meaning that the celebrities haven't actually died. But if a model often learns to associate that whenever there is a text saying a celebrity has died to predict they haven't actually died, then this leads to lots of wrong predictions. And it can lead to the right prediction for the wrong reasons, or the model making the wrong prediction for the wrong reasons as well, due to overfitting to these spurious patterns. All right. So to now get back to our model development pipeline, if an end user only gets a prediction, they don't know if the model has arrived at this prediction for the right reasons or for the wrong reasons. In addition to, they don't know if it's right or wrong. I mean, they might be able to tell. So what we would want to do with explainable AI is to say this end user should also have some way of inspecting the model. So to turn the model from a black box model into some kind of white box or gray box model, such that they can have a look at what the model has learned and how it's arrived at that prediction. And then the end user can say, okay, this model has made the wrong prediction, but for the right reasons, or the right prediction for the wrong reasons, or so on. And then provide some feedback to the person training the model and say, okay, based on this, it's been trained on the wrong data, or you know, something else has gone wrong, and then a better model can be developed based on that feedback. All right. So this was a brief introduction to explainability. Now I'll tell you a little bit about how we can build explainable fact-checking models. And again, I'll do that at a very high level due to the diverse audience. So the first thing one can do is called rationale selection. And what this means is you have some kind of claim, like the Faroe Islands are no longer part of a kingdom. And you have a Wikipedia article here with a long entry about the Faroe Islands. And then the label should be refutes. And now what the model has to do is it has to look at the right part of this evidence document. So the right type of sentence. And rationale selection means that what is checked is if the model focused on the right sentence for making that prediction or not. And if the model arrived at the right prediction by also looking at the right sentence, then we assume it's learned something meaningful. And if not, then not. And there is a rationale selection for sentences. And there is also a rationale selection for words. And this here is an example of natural language inference, which is again one of the component tasks of fact checking. So here, if the model focuses on you know, the last part about if the adult is holding a stick or not, then the model makes the right prediction for the right reasons. If it focuses on dressed versus walking, it doesn't make the right prediction for the right reasons. Okay. So what is it that's difficult about this? Well, one thing is that it's already very difficult for humans to select which parts the model should focus on. And this is partly because there can be multiple correct explanations for something. There might be multiple sentences from which one can make the inference about the label. And this makes the task very complicated. And another thing is that this leads to such explanation generation models also focusing on different parts of the input. So this here is a heat map where we can see what explanation a human would produce for this sentence. So the sentence is, sometimes Twitter makes me feel like an outsider, which should be which has a negative sentiment. So the task here is sentiment classification. And the human would focus on outsider, or the human who's annotated this data set said outsider as the main reason this is negative. And then some models might focus on this as well, but other models might focus on sometimes or Twitter or feel. And all, you know, thinking about it, these are all valid things to focus on, and which one is really the right one. So this means evaluation of these explainability methods is really complicated. And this is something we've looked at in our research. So one way to evaluate them is to say, do they agree with what humans have annotated with human rationales? But this shouldn't be the only way to annotate or to determine if an explainability method is right or not. The other way is to say, are these explanations important for the model's confidence in a prediction? It's a bit difficult to explain, perhaps. Slightly easier to explain is this faithfulness, which means that if a model only has access to the tokens which are part of the explanation, can it still make the right prediction or not? Or does it result in a massive drop in performance? And the other way around is if the most important tokens are masked, these ones which are supposedly part of the explanation, then can the model still make the prediction or not? It should result in a drop in performance if it's really a good explanation. Then there is rational consistency, which means if two very similar models are trained, they should arrive at the same explanation. And if they don't, then the explanation might not have been very good. And then there is dataset consistency, which means that very similar instances should have very similar explanations. And we've evaluated this for multiple different types of models and all of these different diagnostic properties. And I won't go into the details here, but you can see the results here. So we have, what do we have here? We have human agreement, we have dataset consistency, and so on. And then you have an indication of which of these methods over here results in a score, in what type of score. And you can see on a very high level that these methods, they perform well with respect to different scores, meaning that they're very different from one another with respect to different diagnostic properties. So that's one of the findings of this research. The other finding is that even though they perform very differently, all of them perform better than a random explanation. So if we somehow try to aggregate these scores, they all somehow do better than just randomly picking a token and saying, this is the explanation. So that's good. And there are many more findings, but you can read the paper if you're very interested. Okay, so this was it for rationale selection. And then the other type of explanation is called free text explanations. And what we did there in this study is to say, if we have a claim, we want the model to provide an actual paragraph of text saying why, what the explanation is. And there is a PolitiFact, which is a fact-checking portal where journalists go and they manually annotate claims as being true or false or something else like pants on fire. And what they contain is what's contained there is for each of the claims, there are long ruling comments which are articles written by journalists summarizing evidence and taking a stance on evidence documents, which they also manually identified. And then they come up with a ruling, which is a justification. And we view this justification as an explanation of the overall ruling, which it is reading some of these. So based on this, we can train a model which on one hand predicts the veracity if a claim is true or false or something else. And on the other hand, provides a summary of all of the evidence. And this summary is then the explanation. And we don't just want the model to provide any kind of summary independently from the fact-checking process, but we want the model to provide this explanation or learn to generate this explanation at the same time as learning to predict a veracity label. And in this way, the model can provide an explanation that's somehow, somewhat conditioned on this veracity prediction task. All right. And one thing, again, to keep in mind for this is the evaluation. So because we now have paragraphs and no longer just sentences or words as explanations, we have to take other things into account, like coverage. Does it contain all the important information? Non-redundancy, does it repeat any information or not? Non-contradiction, does it contradict itself within this paragraph? Overall explanation quality. And then informativeness, which means, can a human predict the veracity label based on this generated explanation alone or not? And can a model do it as well? All right, so that was it in terms of generating explanations. Now I just have an overall wrap up and overall takeaways. So the first is, why do we want explainable AI and explainable fact checking more specifically? Well, it's because we want to understand if a model is right for the right reasons. But also these generated explanations can help users understand, one, the inner workings of a model, which is called model understanding, and also how a model arrived at a specific prediction, which is called decision understanding. And in this talk, I only presented methods for decision understanding. Explainability can also enable human in the loop model development and human in the loop data selection. There are some caveats. So there can be more than one correct explanation, which is one of the things to pay attention to. Different explainability methods can provide different explanations. And also most work on explainable AI is done on very simple classification tasks for images or texts, and not on complicated tasks like fact-checking. So there are also different streams of explainability methods, which have different benefits and downsides. And I've not presented so many of them, but I'll mention this anyway. So one is that they perform well with respect to different diagnostic properties, which I've mentioned. Then they have different requirements regarding how much training data they need. So how much training data is required to train stable explainability methods. And then there are a number of other ones, like should they be trained jointly with the other task, or after the main task models have been trained? Do they need to have access to the parameters of the model or not? So are they black box or white box? And then can they only be used for hypothesis testing, or can they be used for bottom-up understanding? And then lastly, can they only be used for one-time analysis of errors, or can they be used for continuous model training and development? So where do we go from here generally? So one is, explanations should be useful to model trainers and also end users. So it's important to understand how to interpret different explanations. One might also want to have a combination of model and decision understanding methods. And also the explanation granularity should be different for different types of users. For example, thinking about content moderation, there you have the end users of the platform, but you also have people doing the moderation. And they might be able to deal with more complicated explanations than end users. And very lastly, there is some research on generating explanations, but there is relatively little work on understanding in what context they are useful and how to really do human in the loop development. So that's the very final thing. So then I just want to say thank you for listening, and thank you for attending this webinar. Thank you to my PhD students who work on explainability, Pepper and Dustin, and also thank you to my colleagues Jakob and Christina who've been part of this work, and thank you to my research group. Here are the papers I've mentioned. If you're interested in our work, you can read those two last papers. Yes, and now there is a little bit of time for questions perhaps, or maybe we take them at the end, depending on what Anders thinks is best.
Well, I think the questions are rather general, so let's take them in the end. And it was
Okay.
a perfectly timed presentation.
Excellent.
So it's we give the word to Maria for the next presentation. So, and please write your questions in the Q&As. We take them in the end. And thank you very much, Isabelle. It's really interesting and really difficult to do these things in this very complex environment. But I think it's really important work.
Thank you.
The word to Maria.
Yes. Hi. Can you hear me? I hope so.
Yes, we can hear you.
Yeah, thank you. So yeah, today I'm going to present an initiative where I am involved as an organizer, and it's about the purpose is to try to address the issue of misinformation, especially in combination with search engines. So here there is an example again, it's about COVID-19, and these are the results you may find when you type the query, can smoking prevent COVID-19 on Google or any other search engine. So common sense will suggest us that it's not a good idea to start smoking to prevent COVID-19. But what happens, especially with more complex queries, I don't know, I can think about vaccines and all the public debates we have now with COVID-19 vaccines. Some information can be very technical, and it can be hard for the user to distinguish between what is correct and incorrect. So all these results that we see here, they can be considered correct by a user. They are all relevant, and they are somehow useful because they are about the topic that the user is looking for. And they might affect the final decision of the user, and they can have very large consequences on the user final decision, as also Isabelle was pointing out about people drinking bleach against COVID-19, for example. So it's very important, the role of search engines and the information they show in the result page, because we saw that can actually affect user decisions. So today I'm going to present the track, Health Misinformation track. As I said before, this is an initiative, and I am a co-organizer of this track. Then I will present some of the approaches that were submitted to the track to identify misinformation in search engines, and I will show some results and a final wrap up. So what is the track, Health Misinformation track? So this it's an initiative proposed in the context of TRAC. TRAC stands for Text Retrieval Conference. It's sponsored by NIST, based in the US, and started in 1992. And every year, there are different shared challenges. So you can think about this track as a sort of challenge, and researchers and people, practitioners in the field, they can participate, they can submit their systems, and then we evaluate and compare systems. So the specific case of the Health Misinformation track is co-organized by me and Mark Smooker and Charlie Clark from Waterloo University. The short-term goal is to improve the quality of the retrieval for search engines, specifically for health search. And also the purpose is to promote credible and correct information. The long-term goal is to try to predict what will be the user decision based on the results that the user gets from the search engine, and try to improve the results of the search engine to kind of help the user taking the correct decision. So in the track this year, what we did as organizers, we provided the participants with a corpus, so a set of documents that I can use to search. And this year we chose the Common Crawl News Crawl. So it's a large set of news web pages that are actually crawled from the web. We took a sample of 4 months, and it was about 1.7 terabyte of data. Then, as organizers of the track, we defined some topics. What are topics? So topics are a representation of the user query. Here on the right, you have an example of a topic. So you can see this is the title, Vitamin D COVID-19. These are the keywords that a user might input in a search engine. And then there is a description that is, can vitamin D cure COVID-19? So this is the kind of questions that the user has. And then we also looked for the answer. In this case is no, and we have the evidence here. And then there is a narrative that's something that was used for the evaluation. It's kind of to describe better what is the user information need. So then there were two different tasks in this track. So one was the total recall task. So the participants were challenged to find all the documents that convey misinformation. So for this case that we have here on the right, they had to find all the documents that were actually saying that vitamin D can cure COVID-19. And the purpose is to identify them so that we can either filter them down or put them lower in the list. And the second task, we will focus on the second task in this talk, is the adopt task, and it's a ranking task. So it's very typical of the search engine case. Given this query, you need to rank all the documents that are relevant for this query. And in this specific case, as I said, we want to promote documents that are also correct and credible. So participants had to produce this ranking of documents where at the top of the ranking, there were the best documents in terms of relevance, credibility, and correctness. So this was an overall idea of the track. And now I will present you two different approaches from two teams that participated in this track. But the first thing I will present is BM25. So if you work in IR, you know very well what BM25 is. BM stands for best match. This is a really simple baseline, and it's whenever you have a ranking problem and you want to generate a ranking of documents, the first thing you try is BM25. It's a very simple baseline. There is no machine learning involved. It's just about the frequency of terms. So if we ever look at this equation at a high level, so this will return the score of a document given the query. And then the higher the score, the more relevant is that document for the query. So the higher we should rank this document in the ranking. And you can see this is the FTD is the frequency of the term D. And this term appears in the query queue in the topic. So this is the frequency of the term in the document. And this model actually just used the frequency of the term and this weighting schema here, which is also based on frequency of terms. So it's very simple. And this is the basic step we usually do in IR. And you will see it's both used by both teams and approaches I will present. So the first approach was from KU. Both me and Isabelle were involved in this team, and we had the help from Lucas and Dustin, two PhD students at DIKU. So what we did, as I said, we start with BM25, and we get this first ranking here. This is just ranked, documents are just ranked by relevance. And then what we did for these documents ranked with BM25, we tried to estimate the credibility and the misinformation score. Once we had an estimate of credibility and misinformation, then we merged these scores and we produced our final ranking. So how did we do this in details? For credibility, so to estimate the credibility of one web page, basically we use two different types of features to represent the documents. Some were based on the content. So for example, the readability of the text, and some features were based on the number of definition of CSS, for example. And then we had some popularity features, as for example, page rank, or if the domain contains like the .gov or .edu keywords. Then we trained very classical classifiers as SVM or logistic regression with the Microsoft credibility dataset, and we predict credibility. For misinformation, we treat the problem as a stance detection problem. So this was included in the fact-checking pipeline that Isabelle presented. And basically what we had from these fact-checking problem methods is that we have a probability that the document agrees with the topic. So for example, in the previous case that vitamin D cannot cure COVID-19, and the probability that it disagree. And then we basically consider this difference. So the higher the score, the more the document agrees with our topic. And then we used Roberta to represent documents and the fake news challenge dataset for training. As I said, we merged all this core after standardization and and then we used some weighted averages or some rank fusion approaches from IR. The second approach I wanted to present you is from Waterloo University. Again, you can see here on the left, they used BM25 as a starting point. They also did some expansion, but basically the main, the first step is really the simple BM25. And then they did some re-ranking. So the first re-ranking step is based on T5, and it's a point-wise re-ranking. It means that we take the query, the document, and we compare their similarity. So more similar is the query, more similar are the query and the document, the more relevant is the document, so the higher we should rank it. And the second re-ranking step, it's again using T5, and it's a pairwise ranking. So the main difference is that now we take one query and a pair of documents, and we return a sort of pairwise preference. So whether we prefer D1 or DJ. And we use this preference again to rank documents. So the reason why we don't start directly with these T5 approaches to rank documents is that basically they are quite expensive in terms of computational power. So we cannot really afford to do this. So that's why we use BM25 as a starting point. And then the last step, they use again this T5 model to predict how much the document basically supports or rejects the topic. So what is T5? Very quickly, it stands for text-to-text transfer transformer. So 5 Ts. It's a deep neural network model based on transformer. It's pre-trained again on the common crawl dataset, but it's a much larger and clean version that they use. And it was proposed by Google. Basically, it's a model that can be trained for different types of tasks, all of them dealing with text. So let's go and have a look at the experiments. As also Isabelle pointed out, evaluation is very important. And one of the problems we had as organizers when we ran this task was how should we evaluate the results of these systems. So the participants, they run their system and they return us a list of documents for each query. And then we actually need to associate a score to each list, to each system. So what we did for this specific case, each document was labeled with 3 aspects: useful, correctness, and credibility. And Correctness basically was looking at whether the document was answered correctly to the question in the topic. And then we divided these documents in two sets. Let's say documents that are helpful. So they are useful, correct, and credible. These are the best documents we can have. And documents that are harmful, where useful, incorrect, and credible documents, they're the kind of worst documents we can have, because those are the documents that are really misinformation. Given these two sets of documents and the preference among them, we used a compatibility measure. So here you can see a plot where we have on the x-axis here the score of compatibility for helpful results and harmful results here. So in principle, we want this harmful score to be low and the helpful score to be high. And these are all the systems that were submitted to the track by different teams. So you can see here in blue the BM25, so our baselines. You can see that, for example, these use just the title, and this also uses the description. And if we use the description, so the small question, not just the keywords, we can see that we increase the harmful results. And basically what happens is that when we use the description, we had some keywords as cure or prevent, and these actually seems to attract misinformation. So now if we have a look at this plot here, if we slice this plot vertically, the idea is that all these systems, somehow they have more or less a good score for helpful results, and the better systems are those that are kind of low here, and they have a low harmful score. So these ad hoc results are how our KU runs. So we can see that we actually were quite good in finding helpful results, but we need to improve our system to reduce harmful documents. And these are the results, this H2 from the Waterloo team, so that they could actually, maybe this green one is the best system, which has a good score for helpful documents results, and can keep the harmful documents at a low score. So just to wrap up, what we see is that there are very promising solutions to solve this problem based on neural network models and fact-checking models to detect misinformation. The track we run next year as well. We will have a new task next year, and it's about predicting the user decision based on the results that we show. So again, we will have some future work next year dealing with evaluation and how to account for the user decision when we evaluate these systems. So thank you.
Thank you very much, Maria. We have 1 minute for one question before the break. I take one from IPIC, Barry Slicht, directly to you. So how to define the evidences that might not contain misinformation? In other words, which references, sources did you use for labeling?
So I'm not sure if I understand correctly, because I cannot see the question, but yeah, the labeling part was done by NIST. So and what we used to kind of define whether we provide a small an evidence, a URL to a document to decide whether the basically document was correct or not, or to answer the question that actually we had in the topic. Of course, this was kind of, we can imagine like a sort of simulation, because when we prepare all the topics as organizers, it was a bit hard. I mean, we were in the middle of the COVID-19 pandemic. The information were, keep on changing. So we tried to select some reliable sources, some, based on research papers and so on. But we are well aware that this might not be the correct answer. And this is a problem. Like, this was a specific case, and it's like an initiative. But when you do it in the reality, it's actually a problem to know what is the real answer. I guess this is goes to the ethical part of the this issue.
Yes, well, I think we're gonna have a break now. Maria, thank you very much. It's really, really interesting. And I can see in the questions that both of your presentations have given some really, some really interesting questions out there. So we'll have a short break until 3 o'clock Danish time, where Jonathan Manfield will be giving a presentation, and then the Q&A afterwards. So see you in 9 minutes. So please go ahead.
Thank you, and it's very happy to be here. And let me start out by saying, can you hear me okay?
Yeah. So, all right.
Okay, I think that's your side, Anders. So let me start out by saying, do you have the undesirable public speaking quality of speaking quite fast and sometimes accelerating? So I do have the Q&A open, and I would love if this was interactive. If they're short questions, I'll try and field them as we go. And as Anders mentioned in the introduction, it's certainly a hot topic, potentially destabilizing democracy. I mean, it's on the news every day. It's motivated us to go out and create a startup during COVID. And there's also been some sort of backlash against social media and tech. And part of what I want to convince you today is to justify why we should all make an effort to protect that, and why now is the time for leaders to act. And as a disclaimer, we will look at some big tech examples in this slide, but the AI and the engineering at those organizations is world class, and we're not here to discredit them in any way. We're even fortunate to have team members from some of those organizations. So we selected those companies as they are leading the way in engineering and transparency. So today I'll try and convince you why content moderation will become a strategic priority. First of all, a little bit about me. As I say, I'm a software engineer and NLP practitioner, but when I'm not presenting alongside Isabelle, introduced as an AI specialist, and more broadly as someone who simply cannot escape building real-time monitoring systems. She landed my first job at a hackathon building a monitoring system, and the first job was to build another monitoring system, and now we're doing it again at CheckStep. It's great. And I would say all of the places I've spent time in my career, the news and social media have been of paramount importance. Signal AI, news analytics is the lifeblood of what they do, and they've been very successful in forging a partnership between academia and industry. And it's something we're striving for at CheckStep. In that sense, we do want to democratize greenfield research and be an example of startups that can achieve it. In the investment banking world, it's just as important, especially on the real-time risk desk where I was based. We're very interested in market shocks from news, real or fake. And as we know, tweets do move markets as well. On the retail banking side, I spent some time at JP Morgan, and they're very interested in brand safety and forging a direct connection with potential customers of the bank. Today, I'm at CheckStep and also at Oxford at the Said Business School, where we're designing a technology transformation program to help organizations adopt AI specifically for content moderation. On the same sort of time horizon, I think we've all had a turbulent time, and the media and the news have had a key role to play there. We've had the UK-EU referendum, we've had the Donald Trump-Hillary election, we've had COVID-19, and this was when we actually started CheckStep, trying to raise awareness of dangerous misinformation around viral health claims and present crowdsourced wisdom so people can educate themselves in the wake of dangerous examples like what we saw in Isabelle's presentation, bleach cures coronavirus. we do believe this has been the catalyst for some legislative announcements, and we will see a change. And as recently as December, we've seen a global trend of new laws coming out, and we'll take a closer look at them over the course of this presentation. And finally, I think the most severe and perhaps unprecedented event is the storming of the US Capitol. So at CheckStep, we're starting a company to empower organizations to grow healthy online communities. We have experience building these systems at internet scale, and we want to make them universally accessible for other online organizations. We're also privileged to have a research background with Professor Isabelle Augenstein and Professor Preslav Nakov. So for today, the agenda of the talk, we'll take a look at the motivation for leveraging AI to analyze UGC and some potential applications. We'll also have a look at the social landscape outside of big tech and who are the potential organizations who could suffer from the new legislation, harmful content, who may not have the AI centers of excellence that big tech possess. We'll take a look at some of the threats of harmful content and also the dynamic legislative landscape. And finally, some content moderation solutions with a focus on AI. First of all, I want to show you this graph. This graph is from 2009, and it's an analysis of every YouTube video with a 5-star rating. And there's an interesting property about this graph is that every single rated video was actually rated 5 stars. A very small number were rated stars 1 through 4. So they've made an iteration on the user interface to allow users to express more sentiment, but it's actually not useful for us to gain a high-level analysis. A deeper understanding is required. We need to leverage AI for computer vision tools and natural language processing to understand the content itself. One of the first studies I was involved in was to look at sentiment analysis around the UK referendum. We are looking at whether Twitter believes it was to Brexit or to Remain. And in the outside press, we very much were led to believe that Remain was the most likely outcome. But Twitter was telling a different story, and it turned out it was a more accurate story as well. You can see I've highlighted a few areas on the UK map where there's significant overlap between the Twitter sentiment and the actual outcome of the result. Another application, and this was done during my thesis at Signal, was the ability to alert on news events that were anomalous. So we use a pairwise similarity metric to first cluster the news articles to reduce the volume so that analysts can focus on specific major events. And then we also achieve this temporal distribution, and we can use features such as the volume of news articles in order to specify whether or not that those are anomalous. Finally, and a fourth experiment perhaps is, can we leverage this as an investment strategy on NASDAQ stocks? And here we have a correlation matrix. We have social features, it's data from Twitter and StockTwits, and also financial market features. And what you see generally is a very weak correlation, especially the positive sentiment and financial return is weak. But there is some correlation between the total volume of messages for a specific instrument and the trading volume. So you could potentially use it for that kind of strategy. But a more sophisticated analysis is required to really make this a successful strategy. So with that said, let's take a look at the social plus landscape and some of the social networks outside of the big tech. So in the middle, we have Craigslist. And this was one of the original definitive platforms of the internet for classified ads. And they were able to achieve a broad number of adjacent verticals in a single platform. But as they become successful, competition emerges by addressing the needs of a specific vertical. So every single one of these subcategories from Craigslist has become a successful sector in its own right. And CheckStep is aiming to help these organizations offer a safe experience. From early conversations, we know all of these different organizations are suffering from varied problems, and all of them have some form of content moderation, and the solutions differ as well. Adding a social feature is a competitive advantage, and we see that unbundling Craigslist actually unlocks internet GDP. For example, Airbnb have leveraged the social feature for connecting homeowners to potential tenants, and their revenue for a single category on Craigslist is larger than Craigslist in its entirety. And broadly, this has allowed for businesses and entrepreneurs to compete in a way that was simply not possible with traditional media. And we believe this is worth protecting. Another example of growth is from Pinduoduo, the fastest ever growing e-commerce startup in China, whose growth is actually outpacing some of the big tech organizations. Again, by leveraging a social feature, but again, adding a social feature comes with a cost. Take a look at some of the threats of harmful content and the true cost of offering a social experience in a platform. We do believe there's two broad types of harmful content: high volume and high impact. This data is from the NYU Stern report on content moderation, and we're looking at Facebook Q1 2020. Facebook was selected for this report by NYU Stern because they have the most detailed transparency report so far. On the left, we can see all of the content removed by Facebook during that period, 4 billion examples. And noticeably, the vast majority of the content removed was for spam and fake accounts. And this content is an example of high volume, but relatively low impact until these fake accounts actually act. In this small slice here, we explode it to take a look at some of the lower volume, but higher impact examples of harmful content. Within here, we have several different types of graphic content or not safe for work content, and hate speech. Hate speech is renowned for being a very impactful type of harmful content, but it only makes up 10% of this slice here. So you have two types. You have high volume and high impact. And what we notice is there's a difference between engaging in a network where you're working within your network of friends and organizations such as universities versus engaging in these wide open networks like YouTube and Twitter, where there's some degree of anonymity and a global conversation happening. What we see there is an increase in the proportion of content that's removed for hateful conduct cited as a reason. In the case of YouTube, we have 25% of comments are removed for hateful or abusive conduct. And with Twitter, staggeringly, 75% of all of the accounts that are locked or suspended are either for hateful conduct or abuse. And interestingly, the report highlights that the data on the number of tweets specifically is limited, but with new legislation coming up, we should have more transparency on this in the future. So what are some of the impacts of this more harmful content? We've seen a dramatic rise in the negative evaluation of China. Each chart here shows a country and the viewpoint they have on China. The blue line is the percent of respondents who express an unfavorable view. And we've seen a very sharp rise in the number of respondents who do hold a negative evaluation. We believe social media has had a role here. In the US, 73% of respondents now view China unfavorably. We've also seen a rise in conspiracy theories, such as QAnon. And we highlight the point at which COVID-19 occurs. And you see this has been a catalyst for extreme growth in the number of followers on QAnon groups. Interestingly, AI is also part of the solution in undermining this conspiracy theory. Here we have an algorithm which identifies the style of writing, and it very much highlights that there is two authors using the pseudonym Q, which undermines the entire conspiracy theory, which expresses that Q is an author who has a high level of clearance, and that's why they're sharing this information. Vaccine skepticism is another effect that we're witnessing. Here we can see a sharp contraction of participation of willing respondents who want to take a vaccine. The orange dots here are the August 2020 survey, and the purple dots are the December 2020 survey. And for several countries, we can see over a 6-month time period, there's actually a reduction in the number of respondents who are willing to take a vaccine. In France, we've seen that number go from 60% to 40%. Another area we're concerned about in content moderation is if malicious actors are able to wield generative AI. We've already seen experiments where GPT-3 has fooled Hacker News and an authored article has made it to the top. Separately, we've seen that viral Deep Tom Cruise can produce an exceptionally convincing deepfake, although a caveat here is this is a professional impersonator, and it took several months to produce something this accurate. So this level of quality is not yet widely accessible. Having said that, there is a rise in the number of tools for educational purposes and for training purposes that actually allow you to produce virtual avatars. So the risk here could be that the volume of content malicious actors are able to produce could outstrip the level of defense human moderators are able to provide. So these events have caused focus around platform or publisher responsibilities. And it's a change from the protection that was put in place as the internet was growing to allow platforms to remain protected from the content publishers were putting on their site. As part of a global trend, we're seeing this happen all over the world. But to cover 3 specific examples, in the UK, we'll have the Online Harms Bill. This includes content such as child abuse, terrorist material, and suicide promotion. The content must be removed and limited, or the organization can be fined up to 10%. If they fail to remove the content, they could actually have their service blocked, and we may see this happen. Also, if the content is removed, a reason must be given. So to link to Isabelle's presentation, this highlights the importance of explainability, not only as a reason to give to the end user, but also to help the content moderators make an educated decision and defend their judgment. Similarly, in the EU, we expect the Digital Services Act. Here, there is a focus on flagging illegal content and the ability to contest a content moderation decision if you don't agree with it. So again, if the platform makes a decision you're unhappy with, you have the ability to appeal it. We're starting to see some movement on Section 230 as well. And the very first piece of legislation is the Biden Safe Tech Act. So finally, we'd like to take a look at some of the solutions in place today. From the same NYU Stern report, we present the Facebook flow for handling harmful content. Offensive content can be flagged in 2 ways. It can be flagged using AI classifiers, which are trained specifically for the purpose of spotting content that breaches that policy point, or it can be reported by the community. Once it's flagged, it's reviewed by one of 15,000 human content moderators. And if they believe it violates the community standards, it's removed from Facebook. And this is an error-prone process. 10% of decisions here are made in error. For high-profile cases, they will now loop in an independent oversight board who will be able to override the decision taken by the platform. There's a few trends that are happening here as well. We're seeing organizations place an increased focus on human moderators. In 2013 at Facebook, there was only 1 human moderator per million users. That number has increased 10 times. Today we have 1 per 160,000 users. And in terms of the role, they have 30 to 60 seconds per item to review it and make a decision. And over an 8-hour shift, content moderators are expected to review between 600 and 800 examples. So how effective is AI? We mentioned that content can be flagged by AI using specifically trained classifier for that policy point. And we see here the percent of content which ultimately ends up being removed, which is proactively flagged by AI. So 90% of hate speech flagged by AI before it is reported actually goes on to be removed. Now, this doesn't mean that 90% of all hate speech on Facebook is successfully removed by AI. It's proactively flagged, but it still goes through a human review process. And also some content escapes the content moderation. And to analyze how much escapes, Facebook produced these prevalence metrics. They produced these prevalence metrics by sampling 10,000 examples and measuring the number of content pieces that violate a specific policy. Noticeably, in the transparency reports, we don't yet have the number on hate speech, but we see for violent and graphic content, the max prevalence after moderation is 0.1%. So they're having some success in harnessing AI as a tool for flagging this content. At Facebook, at CheckStep, we want to make the same technology available for other organizations who want to leverage AI to flag the content that's unwanted on their platform. We also, as mentioned, we also want the explainable decisions, so moderators are able to defend their judgments and reduce the error rate. This will allow other organizations to stay a step ahead of the dynamic legislation changes we're expecting. So why is content moderation a strategic priority? We've seen that social features unlock internet GDP. Platforms face existential threats, like the big tech deplatforming of Pall, if they fail to keep their experience safe. There's a global trend of legislation bringing increased focus on content on the platform. And finally, AI is an effective tool for enhancing content moderation efforts. For further reading, recommend the NYU Stern report on who moderates the social media giants, and also the Ofcom report on the use of AI in online content moderation. And finally, the Social Plus blog series by Andreessen Horowitz, who profile some of the success of vertical social networks. Thank you very much for listening.
Thank you very much, Jonathan. Perfectly timed. I will invite both Maria and Isabelle to join the discussion now. And we have some questions in the Q&A. There's some general questions also, so I hope you... So the first two questions is from Sergei Bogachev and Sebastian Schwemer. The first one, do you distinguish between misinformation and disinformation when trying to detect such content? And it's maybe also connected to the Sebastian's question about harmful information versus illegal information. How can the balance between the fundamental rights, freedom of information and expression, so forth, be ensured when using automation in the field of lawful but awful content? Are e.g. procedural ex post safeguards sufficient to mitigate type I errors? And how to even define the standard for what constitutes an error when we're looking at gray areas of information? So it was asked during Isabelle's presentation, but I think also Jonathan mentioned some of this, and it's also very relevant to Maria's presentation. So Isabelle, please.
I'll maybe start with the misinformation versus disinformation part, and then Jonathan can jump in, or Maria as well. So generally, it's very difficult to distinguish misinformation, disinformation by just looking at the raw text. One way in which they can be distinguished is that with disinformation, there is really intent, there is some malicious intent. And this means when looking at who spreads this information, that can provide some kind of signal for determining if something is misinformation or disinformation. For example, there are these troll farms or disinformation bots who retweet one another on Twitter or reshare their information. And looking at which network of people spread information is a very useful signal to understand if something is disinformation or not. Whereas this doesn't hold in the same way for misinformation, where an error was just made by mistake.
Yes, Jonathan?
Yeah, so probably add to that when we approach this as offering a service, one thing that's clear to highlight is that CheckStep is not a truth machine. You can't send us content and we can't send back true or false. So we have a few approaches. We may be able to automatically check previously fact-checked claims. So for a rumor that's undergone the process of investigative journalism, for something that is semantically similar, we may be able to detect that. The other thing that we can do is a semantic analysis of the text itself to see if propaganda-like features have a high score. So if it's leveraging leading languages, or it's very patriotic, or it's very biased towards specific entities, this could be an indication. But again, it doesn't lead us to a true or false answer.
Yes, Maria?
Yes, so for the specific case of the health misinformation track, we didn't focus on this problem. And one of the reasons is also that with health-related topics, it's hard to say sometimes what is correct or not. So even for the COVID case, for some of the topics, the actual correct answer changed over time because of new findings. So yeah, we assume it's misinformation, and we don't distinguish between them.
Yes, thanks. The next question is was also during Isabelle's presentation, but who will get benefits from these explanations? We already have explanations from fact checkers, and automatic fact checking is still far away. So maybe also another way to give a question is what would your practical advice be to companies going into this, and to governments going into this, to using AI for these purposes? So Isabelle, maybe you can start.
So I think Jonathan partly answered this during his talk, and I also tried to provide an answer at the end of my talk. So, I mean, explanations can be useful for end users, but also for content moderators. And I think those are the two target groups. And of course, there are some claims which have been manually fact-checked, for which we have explanations. But when we have new and emerging claims, we won't have these explanations ready somewhere. We can just retrieve them. So then the model would need to generate an explanation still.
Yes, Jonathan.
Yeah, I'd say just to build on that, I think the moderators can benefit in terms of training and in terms of the ability to defend their judgment. I did notice there was one comment in the chat field there around if surfacing these explanations to the end user in real time could potentially prompt them to generate more adversarial examples, and that is something to be aware of. And maybe it doesn't make sense to allow them this quick feedback loop to circumvent the moderation policies. Similarly to when we decline a credit card transaction in financial systems, we don't specify the exact reason in real time.
Yes, Maria.
Yeah, I think I have nothing to add. I completely agree with both Isabelle and Jonathan.
Thanks. And next question from Sonia Villayukuma regarding evidence selection used for veracity prediction. In a scenario where I take a news headlines and check for veracity, how can I be sure that the model only searches for evidences that aren't, again, misinformations? So Isabelle, yeah.
So I think that's an area where Maria has done a lot more work than I have. So it's about the credibility of the underlying sources. And of course, you only want to select evidence pages from reliable sources. Maybe Maria can expand on that answer.
Yeah, so it's still a complex problem. I mean, we can try to search for reliable sources, but sometimes that's not enough. And I mean, this is the whole purpose behind the health misinformation track. So it's a work in progress, and there are several solutions, but it's really a challenging problem for all the things we have discussed before. So to estimate credibility, there are several methods. We can use some features based on the text. For example, how easy, which types of terms are used, more scientific terms or common terms. There are some features we can use, for example, on the web page. If there is advertisement on the web page, that might be a sign of spam or something like this. I saw also a comment from Paolo Rosso about sentiment. That's also something which is considered as well to estimate the credibility of a source. So if there is some sort of terminology that involves sentiments or positive, bad sentiments, or it's more like neutral. But yeah, it's a lot of, the answer makes a lot of sense, and there is no clear solution right now.
Yes, well, we only have 2 minutes left, so so concluding remarks from each of you. What's the next steps in your research and your collaboration? What do you want to do now? And let's take another role. Jonathan, you start.
I think there's so much left to do. We consider ourselves 1% done. Today it's very much a human in the loop style development, but what happens as we move towards a streaming future and situations where it's not possible to have a human in the loop, we need to see a step change in the quality we have, and especially the ability to combine a signal from video and text.
Yes, thanks. Good point, really good point. Maria?
Sorry, I'm trying to tap a question.
we go to Isabelle.
Right. So I think the main thing we need to do is to look at in what context explanations would actually be useful and how to best incorporate them. And there were also some questions around that. And I think it's still a very much an unsolved problem.
Yes, and Maria? The final words. Unfortunately we're running short of time. It's really interesting and some really good questions from the audience. Maria, the last comment before we.
Yeah, no. Sorry, I was busy answering questions. Just the general. Sorry, just a general comment.
Yes.
Yeah, it was a pleasure to be here to have all these questions, and I mean, really a lot of questions and a lot of suggestions for future work. So thank you very much to everyone.
Yes, and we keep the webinar open, but we close down the official part of it, so we can look at the questions and answer them. But thank you. I think it's really interesting and really important work, and a lot of work to be done, both for research and for companies and for governments and for all our democracies. So so thank you very much.
Thank you.
Thank you.